So, for 21 years I've had this electric gate system which I installed myself using equipment provided by a company called CAME, C-A-M-E. This is the CAME ATI electric gate system. And for the first 13 years it worked fine. But then I found I had to replace the motor unit, which is the unit I'm pointing at now. Now it's 8 years further on, and people are finding that the gate motor does not start unless they jiggle the gate physically. Whilst investigating this, I found that it's sometimes stuck in the open position, even though I could hear the relay operating to try and start the motor. And I discovered that I could start the motor by just giving it a bash upwards, like that. So this is the motor after I broke it open on my workbench, or rather half of it. This is the lead screw that actually pulls the gate backwards and forwards on this nut that runs on it there, and that's in perfectly good condition. This here is an epicyclic reduction gearbox, which is 1 in 36 reduction. That's a bearing there. And then this is a cover that fits over there. You can see those lines match those lines, and the rest of the motor is off the screen to the right. There's the same epicyclic gearbox. And here's the motor, which is actually pointing in the wrong direction. This the output shaft of the motor here engages with that. It's the input shaft of the gearbox, so that motor should be turned round. You can see this is an 8-year-old motor, and all this is sort of corrosion of the aluminium housing. It's supposed to be, it says it's rated at IP44, but it doesn't seem to keep the water out very well, in my opinion. This thing here is a solenoid and a brake disc here. This disc is sprung pushed towards the right, where it engages with a flange on the motor spindle. So without power, the motor is automatically braked, and by applying power to this solenoid, you can take the brake off. This is the ZA5 CAME controller board, and power comes in from the mains here, neutral and live. Both sides of the mains are fused at 5 amps, and it then goes up here onto this connector, which connects to the transformer, which transforms it down to 12 volts and 24 volts. This is a 5-volt regulator, and it generates DC for the electronics over here. The DC is fused here. There are 5 relays, which I call relay 1, 2, 3, 4 and 5, which control the motor. This is the connector for the motor, and it has U, V and W wires, which immediately made me think that it's a 3-phase motor, but actually it isn't a 3-phase motor, it's a single-phase motor. And there's nothing on this board that could possibly generate 3-phase, because there are no power semiconductors and no inductors on this board. These 3 relays control the power to the motor, and if I look at the back side of the board, you can see that the neutral from the mains after fusing goes to this relay here, and I've not traced out the whole of this board, but I've traced out this part of it, the mains powered part of it, just to see how the motor is controlled. The motor in this unit is a single-phase induction motor, and the problem with single-phase induction motors is that they can't start by themselves without additional arrangements. I think the motor in this CAME unit is what's called a permanent split capacitor motor, as shown here, where you have two windings at 90 degrees, a main winding and an auxiliary winding, and there's a capacitor in series with the auxiliary winding to induce a certain phase change between the currents in these two windings, and it's that phase change in the auxiliary winding that causes the motor to start moving. Once it's moving, the main winding is driving it. The motor in the CAME unit is actually symmetrical in that the main winding and the auxiliary windings are identical, and that's just, I've drawn them like that. The overall circuit is like this. The live comes in here to the W connection, and we've got the neutral, well, not necessarily the neutral, but U and V are connected to this thing called CT, which I suppose stands for centre tap, which is slightly misleading. But if you put CT down to 4 here, then it is the same as neutral. And if you put it to slightly higher taps, then there is slightly less voltage between CT and live. So these are the 4 taps to control the torque of the motor, number 4 being the highest torque, number 1 being the lowest. So if we close this switch here and effectively apply the neutral or the low voltage, low side to U, then this is the main winding and this is the auxiliary winding, and the motor goes in one direction. If we open that switch and close this switch, then this one becomes the main winding and that one becomes the auxiliary winding, and the motor rotates in the opposite direction. So you can see that CAME is using here, they're using the transformer, the primary of the transformer, as an auto transformer just to control the voltage that goes to the motor. And the secondary just supplies the low voltage for the electronics. In fact, the circuit is slightly more complicated than that, because in series with the W winding, they have a bridged rectifier which creates DC from the AC current that's flowing in the W signal, and applies this to the brake solenoid. And there's another relay which is just on whenever the motor is moving. So when the motor is on, the brake solenoid is actuated and therefore the brake is released. If this kind of motor runs but fails to start, it's almost certainly due to the capacitor failing. So this is supposed to be 10 microfarads. So let's see what it actually is. And we'll put that on 100 Hertz. It's 1.6 nanofarads, and it's supposed to be 10 microfarads. So clearly it's failed. I can't actually find in the UK the exact same capacitor, but I can find this one, which is by the same manufacturer and exactly the same specification, except that it has this bolt on one end. Whether one can fit this in the available space, I'm not quite sure, but one could certainly fit it in the available space if one just hacksawed the bolt off. And this only costs £7 or so from RS Components. So that's the way to go if your motor is hesitating to start, as mine was. So I paid my £7.44p and got the gate going again, didn't I? Well, actually, no, I didn't. I was so horrified by the internal appearance of the motor that I just bought another one for £275. if you're going to buy a new gate motor unit, it's worth shopping around, because I found a difference between some vendors charging £500 and the one I went to charged £275. The reason I didn't replace the capacitor really was because I hadn't quite thought about it properly and didn't instantly realise that it was this kind of induction motor. So we live and learn. But anyway, now I've got a spare motor, albeit one in a rather corroded state. Thanks for watching.